Oh yeah, we did the can. That's right. You guys did. Yeah, you did the implosion you guys got scared about, which I'm still amazed at how many people were shocked by it. Like, I showed you a video ahead of time saying, hey, this is what we're going to do. It's just that element of surprise, you know. All right. Molarity, guys, it's a big thing. This is where chemistry really takes place, in solutions. It's why it's such a big topic that we're going to talk about, because if you think about it, most of the stuff that you've done this year, when we've done any reaction we've done, guys, has really been in solution. Okay, I've given you different ones, like the acids or bases that we've looked at, that we will look at. It's all in that kind of aqueous sort of liquid solution phase. And how we measure that, the number one way, is with molarity, guys. Notice this is an extensive property. What does extensive mean? Review from like Unit 1. Vocab. Extensive versus intensive. Let's talk about intensive.
Isn't extensive like it works for like everything?
No, not exactly. Extensive and intensive, guys, again, for a quick review, one is like inside the substance, one is kind of outside the substance, meaning it depends on how much of the substance you have. So which one do you think depends on how much substance you have? It's tricky like that. Extensive. Extensive is how much of a substance. So what's an example, guys, of an extensive property? Obviously molarity is. Okay. What's another type of that depends on how much you have? Things that we've used all year long. Mass, right? If you have more mass, you're going to have a different size. So what goes right along with mass? Volume, right? So volume and mass are two of the biggest examples where it depends on how much of the substance you have. Now, if we think about mass and volume, what's another quantity or property? What'd you say? Density. Now, do you think that's going to be extensive? No, because that stays the same. It doesn't matter how much water you have. What's the density of water? 1, okay? So density, guys, would be an intensive property. Something like melting point or boiling point. It doesn't matter how much you have. It's still going to melt or boil at that same point, okay? So extensive, maybe you want to jot this down in your notes. Extensive depends on how much you have. Extensive property of values or amounts, guys, they can change. Intensive, they stay with the substance. They're like the identity of the substance. That's why we can use density to determine unknown substances, because it doesn't change regardless of the amount you have. It's a ratio between mass and volume. Molarity, guys, is a ratio as well between moles of solute and liters of solution, but these two values will change. Okay? These two values will change, so the ratio is not going to be that same piece. All right, notice our units, moles. What's our value for, or what's our variable, guys, for moles? What symbol represents moles? That's our unit, not our variable. We used it in our last unit. What's that? N, right? Lowercase n for moles. Liters. Notice it's not what? It's not milliliters, guys, so it is liters. It has to be in liters every single time. So other ways you will see this formula written, capital M equals N over L, moles per liter. Notice it's a capital M for molarity. You've got to make sure, guys, that it is capitalized. If it's a lowercase m, it's another calculation or another value called molality. We're not really even going to talk about molality. We'll kind of introduce the definition, but that's it. Molarity, guys, is based on liters. Okay, so we're not looking at a mass here. Let me ask you this. Can the volume of something change based on something like, say, temperature? Right? Yeah, we should all be shaking our heads because we learned about that. What happens, guys, as something starts to heat up? What happens to those particles? They start speeding up, and what will they want to try to do? Spread out, right? Think back to the hands, okay? Those hands, the weird thing that we did. They want to spread out, guys, so volume can change. Now, fortunately for us, we're not going to be worrying too much about it because we're going to keep things at room temperature. That's where molality comes in. When we talk about it, we'll get there. So this is how we measure the strength of a solution. So when I go into my stockroom in the back, okay, and I look at all my acids that I have in the cabinet or my solutions, it's all based on molarity. Okay, it's all based on molarity. Moles per liter. So here we go. Let's jump right into an example and start doing some math. What is the molarity? All right, that's what we're looking for. Capital M equals question mark. Of 250 mils, what variable is that going to be? That's a what?
That's L.
That's L. Is it L? It's my volume. Okay. What do we have to do right away? Yeah, how do we convert that to liters? Bless you. Multiply by 10 to the negative third. So really what we're just doing is moving the decimal place or dividing by 1,000, guys. So you should, my hope is that you guys can do this conversion in your head, right? 0.25 liters is what we'll have there. And a solution that contains 12.7 grams of lithium bromide. Oh, look at what we have to do here. Oh, yeah, you think I was going to make it easy on you? What do we have to do, guys? This is a mass. Yeah, we got to convert to moles. How do we convert to moles from grams? One-step conversion. Divide by the molar mass. Oh, but do we even have the formula given to us here? Oh, no, I gave you the name. You've got to go from the name to the formula. This is where it's all coming back, guys. This unit is going to be the most intensive with writing equations and knowing how to go from names to formulas. So if you didn't master this back, a couple months ago, it's going to haunt you right here. Okay, you've got to be able to go from the name, because if you get the formula wrong from this name that's given to you in the problem, every calculation is going to be wrong. Your number of moles will be wrong, which means your molarity is going to be wrong, which means the entire problem will be wrong. It hinges on whether you can go from a name to a formula. How do we go from names to formulas? Review from Unit 5 on naming. In the name, what should you be looking for?
The ending.
The ending, okay? That's part of it. Also, you can be looking for prefixes. Do you see prefixes here? So if we have no prefixes, what method do we use to figure out the formula? Crisscross. So in order to use the crisscross, what do you have to know about each substance? Their charge. So you've got to know all this information, guys. It's got to be going around in your head to get to where you need to go to. Lithium's charge is? Okay, so if you just went ahead, you didn't think about all this, 1 minus, you got lucky if you just said, oh, it's LIBR for this one. Do you think I'm always going to just make it a 1-to-1 ratio? No, because we're going to use substances we've used all year long. Okay, common stuff. There's our substance. So LIBR is our formula. You've got to look up the molar masses. Guys, 2 decimal places is fine. You can round on your periodic table. If you want to round those values to 2 decimal places, that is okay. So lithium's mass is 6 point what? 941. Plus bromine is going to be... Okay. Add those together. What do we get for our molar mass? Okay. So, 86.844 grams over moles. Grams cancel out. We're left with moles. 12.7 divided by 86.844. How many moles do we have? And 2 decimal places, guys, usually is okay. So you're good if you go to at least 2 decimal places. You should be good. Are we done with our problem? No, we haven't even done anything, guys, to get in the molarity, really. We've had to do all this pre-work to get set up to be able to do this. Molarity equals N over L. So we have 0.14 moles divided by 0.25 liters. What's my molarity going to be? Right, so moles per liter, guys, is our unit. But there's also a shortcut way to write the unit. This is the way you will see it a lot of times. When you look at solution bottles that we're going to use in lab, you will see it written like this most of the time. It's going to say something like 0.56 with a capital M. Okay? Either unit is acceptable. If you put a capital M or moles per liter, you got to put something there. Okay? That means molar. Okay, like a 0.56 molar solution, meaning I've got 0.56 moles per 1 liter of my solution. Okay, so for units, you can either put moles per liter or a capital M. On a quiz or test, though, if you do this, I will take a point off, because there is no unit with that number. Even though you're defining M, guys, I want to see your units, because on your Regents exam, Okay? You will have to write a final answer in your workbook. If you don't put the unit there with it, they may not give you credit. I don't know if they're going to give you credit for this, meaning with the unit. You may lose a point. It's better to be safe than sorry, so that's the way that I'm going to approach it when I'm grading your quizzes and your homework and all that kind of stuff and your test. Is the math, guys, super difficult? No, it's dividing. Okay? But it's that legwork you got to remember to put in. It's got to be those units, moles per liter. Go ahead and try this problem in your note. With our milliliters, get it right away, 2 liters. That's just a good rule of thumb, guys. If you see a volume unit or a volume that's not in liters, just do it right away. Do it right away. All right, we have our mass, which is 32 grams. What's the formula for sodium sulfate? Na2SO4. Good. Remember, guys, just a rule of thumb, if you see 8 or 8, what does that mean you have? You have a, what did you say? Oxygen's in it. You have a polyatomic ion, right? So go right to your list, and oxygen is going to be in that. Absolutely. So you got to figure out the molar mass. It's going to be 2 times 22.99 if you round it, plus 32.07 for sulfur, plus 4 times 16. All right. When you do the math, what do you get for sodium sulfate's molar mass? Okay, 32 divided by 142.05, it should be a tiny decimal, or smaller decimal. 0.22 moles of sodium sulfate. So now you can go ahead and calculate 0.22 moles divided by 0.45 liters. So it's going to be somewhere about close to 0.44, 0.43. Which is it? 0.5. Oh, 0.5, a little bit higher. Yeah, I didn't do my math right. Yeah. Is it 49 or 50? 50 something? Okay. There you go. Easy? Okay. Again, like I said, this is the bigger unit, guys, that we will use in this, really the rest of the year, is molarity. But it's not the only one. So you're not working on that next page right now. We're going to continue with some notes here today. Let's take a look here at this example. Do you guys have this one in your notes? Is it at the top of the page? Okay. So this is at the top of page number 4 in your notes. A little different take, guys, on solving for molarity. It's now asking you, how would you prepare a solution? So before you guys worry about this, I want you to go back to page 3. Okay, before we start solving this, look at what I gave you in your notes. It gave you kind of a description of how solutions are made. I want you to read over that very quickly. Take the next 30 seconds or so and read through those steps on how a solution is made. It's the same type of math, guys, but you've got to explain how you're going to make it. So it's a little bit different wording. How would you make 500 mils of a 0.32 molar solution of lithium bromide and water? Okay, so write down what you have. We've got our volume. What do we need to do to this volume already? Convert it to liters. Okay, 0.500 liters. Are those zeros important in this number? Yes, they are. Why? There's a decimal, guys. The other ones that we had, we just let those zeros go, but there's a decimal point right here, so that makes them significant. We are given the molarity in this problem, 0.32 moles per liter. Okay. So what do you think we're looking for in this problem? Moles. Now, can we measure moles, though? So it's asking you how to make a solution. So what's it really asking us for in the end, guys? Do we have a tool to measure moles in the lab? No, we don't. So what can we measure? Grams. So you've got to take it, guys, not from moles. I mean, you can't just leave it as moles. You've got to get to grams here. That's what this problem is asking you to do. So we got to look for moles first, and then we got to figure out how many grams in the end. So molarity equals N over L. How do I cancel out fractions? Multiply how? You can multiply by, or you can just... You can multiply that or cross multiply, guys, same thing, because this is like saying this over 1. Either way, whatever you are comfortable with doing, liters cancel out here. So moles equals liters times molarity. We have 0.500 liters multiplied by 0.32 moles per liter. Liters are gone. All right, we have 0.16 moles. Now what do we have to do? Yeah, get to grams. Before we were dividing to get to moles. Now we're going to multiply. You already have the molar mass of lithium bromide. We did that in the other example. That mass was 86.844. Moles will cancel out. How many grams do we have then? Now, one last thing, guys. If I ask you on a test, how would you make a solution? You have to describe making that solution. So how could we write this to kind of answer that question, to describe it? To what? Or, yeah, absolutely, Grant. I know it. Take 13.9 grams of lithium bromide and add, now are we going to make a liter of this solution though? We're making half a liter, right? But that's essentially the same thing. And add to 500 mils or 0.5 liters of water. That's your answer for a problem like this. You've got to write that, then stir it up and all that. You could go into that detail, but I'm not going to look for you guys to go, have to say that. Okay? If it asks you how to make it, you've got to describe. So really, guys, the first thing you got to recognize, you got to get mass, and then just say, hey, you're adding it to that whatever volume you want to get. You guys try the next problem. So again, how would you make? We're looking for moles first, but then we're going to need to get grams second. So N equals molarity times liters. So it's going to be 0.50 moles per liter multiplied by the volume of 0.25 liters. Those cancel out. How many moles do we end up with? Okay. Now we will multiply that by the molar mass, guys, of sodium sulfate, which again was 142 point, what was it? What? 05. Okay. Again, if you round a little bit differently, it might be slightly different. Grams per mole, I should say. How many grams do you end up with? Na2SO4. So your final answer, guys, would say add 17.8 grams of sodium sulfate to 250 mils of water, and that's how you make a solution. So when in doubt, in this class, guys, water is going to be your solvent, okay? So you can always say, I'm going to use, add it to that many grams to that volume of water, because that's going to be our solvent that we're going to use.